So this is one of my favorite moments in my job. If you're still with me at the end of this video, you will have officially leveled up from a high school math student to a college math student. What we're doing here is we're introducing the fundamental idea of calculus. So this is what we're going to be talking about for pretty much the whole year. And what we're going to be doing is analyzing how functions change. Right? So last year we studied functions in depth, and now we're going to be mathematicians of change. We're going to study how functions are changing. So that's why I had you do things like average rate of change for me over the summer. So like any great idea, this idea is really simple, but we can make it really complicated if we want to study really complicated things. But we're going to start with a fundamentally simple, down-to-earth example. So we're going to be driving in our car. Make sure you've read the problem. If you haven't already, I'm going to trust you to pause and do that right now. And what we're asked to do is make a graph of f of x versus x, which is our distance, and then this little f dash thing, which is new notation. So if you're concerned about that, it's brand new. Don't burn any brain power on it just yet. But this should be the number on my speedometer. And the way a human says that, right, is just speed. So this graph is my speed. Okay. So this feels like a slope problem, and it is, right? So really you've been doing a little bit of calculus since 8th grade, because slope is a derivative. Slope is what we're learning about. So for f of x to represent my distance, well, if I'm starting at home driving away at a constant rate, it's going to look something like that, right? So I'm starting at 0, and my slope, if I drew rise over run here, be 1 hour to 60 miles, right? So again, that's just a slope problem. You've known how to do that since 8th grade, y equals mx plus b. Now my second graph is the number on my speedometer. So again, real human beings say speed, but I wrote it this way to make it more obvious. So constant rate of 60 miles per hour, that means the speedometer says 60 all day, right? The way I represent that as well, here's 60, and I'm going to draw a horizontal line to represent that it is not changing. That's the only speed I go, right? So again, we have distance versus speed. This is a graph of the number on my speedometer. This is a graph of how far I am from home. This is neither new nor is it rocket science, but we're using it to introduce the new notation and build a little bit of meaning behind some new vocabulary. So this new notation, this f dash thing, the way I read that is f prime. And what it means is the derivative of f. So say f prime is the derivative of the function f. Read that out loud if you're not in a place where it would be weird. F prime is the derivative of f. And this is brand new. And what derivative means? The derivative is how f is changing. So all we did here, really, to make our derivative graph f prime, is we drew a graph of the slope of f. So the slope of f is 60 all day. My f prime is 60 all day. So that's the simplest example. It's an example you already are familiar with. And again, we're just using this to introduce the new vocabulary. Make sure you got all that, because we're about to make it a little more complicated. So our more complicated situation is going to be a little bit more like real life. So imagine instead of driving just at 60 miles per hour all day, our speed changes as we drive. And that's usually how we drive, right? So our graphs are going to be the same, so take a second to label them. So here we have our distance and speed graphs, and we want a speed now that is not constant. So we're going to drive a little bit more like we do in real life, not 60 miles per hour all day. So let's imagine that my speed increases as I go. So I start out like 25 miles per hour, and watch how this increases. It's going to increase nice and smoothly. So my speed is increasing throughout the day. How would I graph that? Well, notice my speed was increasing at a nice even rate. So functions that increase at a nice even rate are linear functions, right? So we started around 25, and then we increase at a nice smooth constant slope. Okay, so what would our distance graph look like? Well, it cannot be a straight line anymore, right? Because straight lines have a constant slope like we had here, in my new graph, my slope is changing, right? So my slope is increasing as my x gets bigger. Well, the way I might draw that is I'm starting at home and I'm increasing at an increasing rate. So I drew roughly half of a parabola there. So the level up here is that curves don't have constant slope, and that's what we're going to learn how to study is functions where the slope changes depending on what the x value is. So the main idea here is simple, right? When I say derivative, or when I say f prime of x, you think slope. That's all the understanding we're trying to build right now. Because once we have that understanding, it allows us to do some interpretation and some estimation. So we're thinking about what these things mean, and then later we'll do the work of figuring out how to calculate them. So now we're going to do some interpretation. So we're given this statement here, f prime of 7 equals -2, and we're asked what it means. And again, I'm trusting that you've read the problem, but we should annotate for what f of x is and what x is. So f of x is gallons of tears that you cry, x is days. So then, what does this mean? Well, I'll give you the whole interpretation here in a second, but before I tell you, what I want you to think about is whether your number of tears are increasing or decreasing in this situation. Pause the video and answer that. My number of tears is decreasing here at a rate of 2 gallons per day. And the reason I chose decreasing is, of course, that my slope, my derivative, is negative. And then notice I said gallons per day. Well, where I got that is my y units per unit of x. Y's per x. Right? So just like miles per hour, gallons per day. So this is a fine explanation, and this is right. But unfortunately, it's not quite specific enough anymore. Because remember, tomorrow, your number of tears might be increasing, whereas 7 days from now, your number of tears might be decreasing. Our slope doesn't necessarily have to stay the same anymore. So what I have for you is a kind of unfortunate mnemonic, nut, to make sure your answers like this are as specific as they need to be. So N stands for noun. That's what we are talking about. So that's tears here. U stands for unit. That's Y's per X. And then T stands for time. So time is my when, and it's my X value. So when are we talking about? So in this particular problem, this would be on or at, we could say X equals 7 days, right? And this is how you would answer this question. And this is an AP style question. They don't ask you about tears, but this is a question they would ask you in the AP exam. So number, unit, time, every time you're asked for an interpretation, we're going to do that in this class. So there's my NUT, my nut, for this particular interpretation. Okay, so the last thing we're going to do, and this will be easy because you already know how to do it now, is estimate a derivative. So take a second to read the problem here, and it asks me to estimate v prime of 17. And notice 17 would be here. In other words, 17 is not given in the table. So how do we estimate it? Well, I'm going to put up the work, and this will be familiar from your summer work. So the way we estimate a derivative, well, we use average rate of change, or we use our slope formula, and that makes sense because our derivative represents slope. So here, this spits out 5. So I don't need you to know how to calculate a derivative just yet. We're worried about estimating them and building that interpretation. And the last thing I want you to do is write your interpretation of this result based on the example above. I'll put up the solution here in a second.